Hello, everyone, and welcome. My name is Francesco, and with today's topic, topic 7, we're going to cover something kind of interesting. What is today's topic going to be about?
Fire! There you go! Light it up! Come on!
Right? Today's topic is fire. So we're going to play around with um, some definitions that I've thrown at you and we've just taken for granted. So here's the context. Do you remember when we covered topic 5 and then topic 6 by extension? This is the topic where, if it can help you remember, we learned that hummingbirds fly backwards. It's where we use this knowledge to work backwards to figure out the construction requirements for a building based on certain characteristics like major occupancy, number of stories, how many streets it's facing, whether it's sprinklered or unsprinklered, and so on and so forth. Okay? And I threw at you a number of definitions, and you kind of just accepted them at face value without me really taking much time to define them for you. And I just want to remind you about definitions in the Ontario Building Code. You find those in Article 1.4.1.2 in Division A of the Ontario Building Code. And you can tell that words are defined in the Ontario Building Code because they're written in an italicized font. But these are the definitions, the words that you kind of took at face value and you just said, oh, okay. I'm thinking with today's topic, we're going to talk more about these definitions, okay? Construction, combustible construction, non-combustible construction, the word just combustible referring to combustible material, non-combustible referring to non-combustible material, what fire separation means, and what fire resistance rating means. All of these words were used to define the results that we got from our backwards hummingbird analysis that we did for topic 5 and topic 6. And today we're actually going to talk more about these, okay? I hope that helps. So let's start maybe with the top two, combustible construction and non-combustible construction. You obviously are going to go and check out the actual definitions that are found here in the Ontario Building Code, but I'm going to give you like a simplified version, a Francesco-fied version of this. Combustible construction is defined as the kind of construction used in a building that is not non-combustible construction. Okay. So what's the definition for non-combustible construction? Non-combustible construction is that type of construction that uses non-combustible material. We're kind of still not defining. We're using another definition to define the previous one. Okay, maybe here. What is non-combustible materials? Non-combustible materials are those materials that are identified through this test. According to standard CAN ULC S114, the test for determination of non-combustibility in building materials. So there is a test or an involved test, and this test helps define whether that material is non-combustible material or a combustible material, I guess. Okay, so what's a combustible material? A combustible material is a material that does not conform to this test. So you're kind of seeing this recursive definition that uses another definition to define itself. Right? Okay. So maybe what I'm thinking is that I can provide you kind of a simplified definition to always remember what these two mean for the purposes of construction and the Ontario Building Code. Combustible, we'll take that as to mean that it's material that will typically burn for typical fires, okay? So for construction material purposes, that's wood, paper, cork, adobe, plastics, and you have those materials that are derived from asphalt derivatives like shingles, that sort of stuff, okay? Non-combustible, we'll call that material that doesn't typically burn. So like concrete, steel, masonry, brick, ceramics, gypsum, and the like. Okay. And I know, gypsum does have paper backing on one side, but it is considered non-combustible. Okay. So I hope this helps a little bit. Okay. Now, what about fire separation and fire resistance rating? Well, according to Division A, Article 1.4.1.2, the definition for these two is as follows. Let's start with fire separation. Fire separations refers to a literal physical barrier that has been specifically built as a continuous, uninterrupted barrier to prevent or stop against the spread of flames, heat, and fire. So it has nothing to do with what it is made of. It's independent of the material. It literally defines a barrier. Make sense? It's literally a barrier. Fire separation is a barrier against fire and heat. Sometimes also smoke can be included. Okay. Material never comes into play. So whether you make it out of cheese or whether you make it out of concrete, if it's built to be a continuous barrier, it's considered a fire separation. Now, obviously, you don't want to make one out of cheese because that's not going to work, but that's where fire resistance rating comes into play. Fire resistance rating refers to a measure of time, whether it's in hours or minutes, that this fire separation can obtain. So depending on the material you use and the layers used in this fire separation, a amount of time in hours or minute can be assigned to this fire separation, starting with 0 all the way to 4 hours, to identify the, the strength, if you want to say it that way, to resist the spread of fire and heat. Okay? The fire resistance rating in hours or minutes is based on specific tests that the Ontario Building Code lists, or assemblies that the Ontario Building Code has already figured out for you with pre-assigned times that are being given to these assemblies. And we'll talk about those in a moment. Okay? But that's the difference between these two. So I want to share with you resources that the Ontario Building Code itself identifies for fire separations and fire resistance ratings. I'm going to call this a 2+1 approach. And that's because sentence 1 and 2 under Article 3.1.7.1 in Division B identifies the first two resources I'm going to give you, but I'm going to add a third one too I want you to know about. Okay? The third one is the +1. So the first resource that's identified is the fire assemblies and resistance ratings that come from applying this specific test. That is the CAN ULCS 101 test, which is the one that the Ontario Building Code identifies as the correct one to assign an amount of time to a certain single piece of material or different kinds of materials that have been put together. This applies, the results of this test can apply to both Part 3 and Part 9 buildings. And basically, this test then can be used to create a catalog, so a list of different assemblies that have been tested, which have then received a corresponding fire resistance rating in time. Okay, so you don't have to figure them out yourself. Somebody has done the testing, put them together, and now they have a list of different types of walls, floors, ceilings, and the like. Okay? The only problem though, getting access to this list of assemblies can be pricey, right? There can be a paywall barrier in front of it. So we're not going to use it in this introductory course, but I want you to be aware of it. Also, I'm going to link for you in the description below a legal free place where I found some examples of these assemblies for walls, floors, and roofs, and they'll be in the description below. So you can check them out for yourself. The second place it's identified points to another spot in the Ontario Building Code, that is Supplementary Standard SB2. Supplementary Standard SB2, we're going to go find out in a moment where this is, applies to both Part 3 and Part 9 buildings. It uses a so-called component additive method. So what this component additive method is, it uses the same method that you or I would use, say, in making lasagna or a sandwich. So you put layer after layer after layer after layer, if it's a floor or a ceiling, or layer after layer after layer after layer, if it's a wall, for example, and each layer contributes a certain amount of time to that assembly, up to 90 minutes. Okay, so here's a limitation for this method. This method only works up to 90 minutes. So if you add the layers correctly, you can only go up to 90 minutes, even if the layers add up to more than 90 minutes. You can find this in volume 2 of the Ontario Building Code Compendium, and I figured, hey, how about I show you? So I'm going to try to make volume 2 appear behind me. Let's see if this is going to work. Oh, I'm hopeful. There we are. There we are. Okay. All right. So volume 2, and I'm just going to open up above me the table of contents right here. And you see right here, table of contents, Appendix A, Appendix B, and then the supplementary standards right here. I'm going to open that up and bring up supplementary standard SB2. The nice thing about the digital copy of the Ontario Building Code is you can just click on that space, right? And right here is SB2. Now I can also open up in the table of contents above here. SB2 contains a number of sections within it. The section that we're going to be looking at for this topic, and really this course, is going to be section 2, which is the fire resistance rating of section. Okay? So I just wanted you to see what this looked like. Specifically, under this section, the part that really we're going to be focusing on are going to be these tables. Table 2.3.4a, 4b, 4c, 4d, 4e, and 4f. Again, I didn't say all the words before, but it's table 2.3.4f. Okay? And the last one is going to be table 2.3.4g. Okay? I hope that makes sense. So I just wanted to show you where that came from. Now, for SB2, there's a couple of other things that I want to make you aware of. There are limitations that are expressed in 2.3.3. So one of them I mentioned is up to 90 minutes that you can get from this method, but you want to read also these other limitations. Furthermore, only these tables will be used. So from table 2.3.4a all the way to table 2.34.4g for the component additive method. Read the title to each of these tables, because in the title, it will tell you if that table is for a wall, for a floor, or for a roof. Okay? So you can only use the values in that table if they apply to a wall or a floor or a roof. You can't just pick any table, okay? But we'll do an example, all right? Now, the other thing too is under the table. So beneath the tables, you're also going to find notes. So inside the tables, you're going to get some little numbers in brackets that look like exponents. Those refer to the notes beneath that table. You want to read those notes, because those notes will tell you whether or not that assembly can actually be allowed to happen. Okay? And finally, I think it's worthwhile if we practice this. Could we maybe do an example? Would that be okay? So let's try this. We want to create a fire separation, a wall. It's going to be a load-bearing wood stud wall, and we want to obtain a fire resistance rating of 1 hour, 60 minutes. Okay? So we're going to create a wall that looks like this. And the first thing we're going to do is identify, when doing this kind of analysis, a so-called fire side of the wall. So where the fire is starting from, because we're going to layer that wall in layers from closest to the fire to furthest from the fire. Okay, that's how we're going to doing the layering of that wall. Okay, so I'm identifying a fire side for you like this. Then what we're going to do, is we're going to go to the tables here and only pick out the walls tables, because this is a wall, so that we don't use the other tables that are not walls table. I'm going to leave that for you to figure it out, okay? But we're going to only use wall tables. So we go from closest to the flame to furthest away from the flame. So the first one we're going to be using is table 2.3.4a. So that's the table that allows you to assign time to a protective membrane on the fire side of the wall, whether that wall is made with wood frame or cold formed steel frame. Okay? So what I do is I identify the column in that wall that relates to load bearing. It is this column right here. And then I pick any of the rows, any of the relevant rows there. And I pick this row here. I could have picked any of the other ones, but I have some experience and I did this a few times and I found this was the best one. Okay, you can pick any of them, go through this process and find out if this is going to work. I picked this one. I picked the row that reads 15.9 millimeters type X gypsum board, and then the entry in that column reads 40 brackets 2. That brackets 2 refers to a note below the table. That note says that value in minutes, so 40 minutes, only applies to wood framed walls. Okay, which is good because that's what we have here. It's a wood stud wall. If here we had the steel stud wall, we could not use 40. Okay, because it only works for wood wall. Okay, so I'm going to select 40. So that means that the membrane on the fire side is going to be 15.9 millimeters thick type X gypsum board. By selecting this, which gives 40 minutes to this assembly, we're also selecting the membrane on the far side, on the opposite side of the wall. Now you don't double count it. So you don't count the fire side and the far side. They both are 40 minutes. You select the fire side one and automatically that includes the far side of that. Okay, you don't double count them. Okay, the next thing we're going to do is figure out the structure of the wall, literally these wood studs. And when you go through it, you find that the next table that has this information is 2.3.4e. Notice the jump from A to E? That's because the other tables were likely not for walls. Make sense? So that's why you want to make sure you identify the wall tables first. So table 2.3.4e looks like this, or very similar in your copy. And what it includes in it is the time assigned for the contribution of wood framed walls or cold form steel framed walls. So I identify the column that has load bearing in it, because that's what we have here is a load bearing wall, and I select the wood studs from the available rows. I select the topmost one, wood studs spaced at not more than 406 millimeters on center. And the result that I get from that column is a number 20, which is a number in minutes. So 20 minutes. So that's the contribution of wood studs spaced at 406 millimeters on center at most. Okay, so that's the contribution of the studs inside this sandwich of gypsum board. Good. The last step is to look at additional contribution that is added by extra protection that can be found in table 2.3.4d and c. Okay, so these two tables contain extra protection. Go check them out to see what kind of protection it is. It can be stuff that you, I don't know, paint on or put on the outside of the wall, or stuff that you can add inside the wall between the studs, for example. Go check them out. We, for this example, are not going to be using these tables. Why? Well, it's because by getting these two elements, we've already achieved the 60 minutes required in the question, okay? But if we needed more, we would look at these two tables for extra protection. So the final answer in this case is that in order to create a load-bearing wood stud wall with a 1-hour fire resistance rating, using the component additive method in SB2, we would select 15.9 millimeter Typec gypsum on both sides, and the stud wall will comprise 38 by 89 millimeters wood studs at 406 millimeters on center. Make sense? I hope so. So let's look then a moment at SB3. What's in SB3? That's the +1 that I mentioned. Well, SB3 contains information about Part 9 only. So SB3 will actually be referenced if you go and do an analysis for a Part 9 building. This is so important that I think I'm going to mention it again. SB3 applies to Part 9 only. So I don't want you to use SB3 for an analysis of a Part 3 building because that's bad. That's the technical term for it. SB3 comprises of over 100 pages, but it's really two things. SB3 is Table 1 and Table 2. And the way that Table 1 and Table 2 are set up is they're a list of assemblies. Remember how I was talking about those assemblies that come from that test? Okay, that I said that you have to pay to get access to that list of assemblies? Well, if you go to SB3, you can have a look at how a similar list of assemblies is set up. The only thing is, the one on SB3 is only for Part 9 buildings, okay? But that's how it's set up. And what it is Table 1 is for the fire and sound resistance of walls, whereas Table 2 is for the fire and sound resistance of floors, ceilings, and roofs. So Table 1 is for vertical members, vertical assemblies, and Table 2 is for horizontal assemblies. So I was thinking maybe I could show you. You want to come on a little bit of a tour? Let me show you what this looks like. Okay. So here is volume 2 again. Let's zoom into it, maybe right here. And what I'm going to do is I'm going to bring up again the table of contents. And in the table of contents here, I'm going to identify SB3 right here. And the way SB3 is set up, if I make that visible up here, there is section 1, which contains the fire and sound resistance of walls, so vertical assemblies. And then there's table 2 right here, which contains the fire and sound resistance of floors, ceilings, and roofs, so horizontal assemblies. So you can see that with the way that this is set up. Okay, I'm going to look at section 2 just because I'm here right now. In the, let me just make this a bit more visible like this. There we go. In this first column, you have the type of assembly. Okay, so it will tell you what it is, if it's a floor, a ceiling, or both, and then it will tell you in general terms what that kind of assembly is. Okay, that's what we'll say there. So this is concrete slab, this is an open web steel joist, and so on and so forth. Okay, and then the next column will have the assembly number. So a number and a letter that is used to identify that specific assembly. Okay, then you have description, fire resistance rating, typical sound transmission, and typical impact installation class. The nice thing about this method and the way that it's kind of set up is that it will give you a visual description of what it is, okay? And it will kind of explain also what the different layers are. Okay, so you can kind of have a look at that. And then automatically, depending on which one you select, you'll get the fire resistance rating that's associated with that. It is literally a catalog of different types of assemblies and corresponding fire resistance rating that comes with it. So be curious and check this out. But don't forget, it's for Part 9 buildings only. So don't make the mistake of using it for Part 3 buildings because it's not correct for that. I think what I want to do is wrap it up by talking about this. Sloped walls. Another way to look at it is this. Walls are typically vertical, roofs are typically horizontal, right? And so far we've looked at horizontal assemblies and vertical assemblies. When does a wall start being a roof? Or when does a roof start being a wall? There is a limit at which you actually go from a wall to a roof and from a roof to a wall. The Ontario Building Code tells you exactly what that angle is under sentence 3.2.1.3.1. When is a wall a wall? When is a wall a roof? Go check it out because, my dear students, this makes for a great bonus question on a test or a final exam. Okay? I'm not going to spoil the surprise, but this sentence here will tell you at what angle a wall stops being a wall and becomes a roof, and a roof stops being a roof and starts behaving like a wall. Hey, I know that. That means that we've reached the end of our get-together. Now, there is no homework, my dear students, about this specific topic, but I am going to link for you in the description below eventually some extra examples that I'm putting together for you. But for now, that will be it, okay? Also, thank you so much for your time. The next topic to look forward to is topic 8, spatial separations. And what it's going to deal with is what happens when your neighbor is someone like this. Okay? Bye, everyone. Take care.